Greetings and welcome to another video about some math with Mr. Plaska. Today we are looking at calculating speed and distance. So in this video we're going to be discussing the relationship between speed, distance, and let's add time onto there. And so with these types of problems, it's kind of a continuation of ratios and then rates and unit rates, but this time specifically talking about speed and distance and time. So before we get too deep into this, we need to establish an understanding here that speed is a rate that talks about some sort of unit of distance per a unit of one for time. So that could be something like miles per hour. And so in this, that's how many miles you would travel in 1 hour. So you could travel like 50 miles or 60 or 70, however many that might be. Or it could be like meters per second or kilometers per minute. But no matter what, you always have some sort of unit for distance. So miles, meters, kilometers, centimeters, feet, yards, any of those, per some unit for time. So we have hours, seconds, minutes, days, years. Again, any of those units. So it's like a unit rate for those distances. And so as you can see, there is definitely, speed, distance, and time. Those three pieces of information have a really interesting relationship and how they work together. So looking at them, we have a little visual that helps keep track of how all of this fits together. So we have distance, speed, and time. And so if we were to think about an example problem that gets us to that triangle. So if we were trying to figure out, like, Mr. Plaska traveled 300 miles in 5 hours, what was his speed? And we think about here, we've looked at rate lines where we're talking about miles per hour. And we know we traveled 300 miles in 5 hours. And so to calculate speed is going to be blank miles in 1 hour. So we know our hour is going to be 1. So using this familiar format, this familiar structure, we know we're trying to find the miles per hour. So there's our missing piece of information. And then to get there, we know 5 divided by 5 equals 1. And so that proportional relationship from long and far ago tells us if we're traveling for 5 times less time, we're going to travel 5 times less distance. And so to calculate that missing value, we would need to do 300 divided by 5, and that is 60. And so I would travel 60 miles per hour. And so as you can see here, what we actually did was this up top here, this is our distance. I'll put that in blue. And we divided that by our time because we did distance divided by 5, which was our time, to calculate, sorry, I thought I'd grabbed my highlighter, to calculate our speed. And so here we can see that we're already starting to get this idea of speed equals distance divided by time. So there's a relationship between these three values. You can figure it out, but that picture just helps you kind of remember them quickly. And this also works the same thing where, let's say, in this case, I guess we'll move into the next ones. But just to know that we are going to be using this triangle and that you can calculate or you can figure out these formulas if you go back to our lessons on unit rates and calculating unit rates and ratios and all of that. So as we get into it, keep in mind we'll be referencing this triangle here to get our formulas, but it isn't just a simple memorize this. It's a here is where these things come from. So in our first example here, Melanie ran 450 meters in 2.5 minutes. Find her speed in meters per minute. So I have two options. I could go through and think about our formula here, or I could use a rate line. And so for this first one, I will do both just so we can check and see. We'll start with the formula, and then we'll check ourselves with the rate line to see. So in this problem, let's identify what information we have and what information we're looking for. So Melanie ran 450 meters. So I know this is a measurement of distance. And she ran that in 2.5 minutes. So that tells me that is the amount of time that she ran. And then the question is asking, find her speed. So we know distance, we know time, and we're looking for speed. And so according to this triangle, we know speed equals, and if you look at the position of these variables like this, we have distance over time, and that is the same as distance divided by time, just based on where they're sitting here. Because if we look like this, if we think of that line like the bar in a fraction, we can see that's a d over a t. So now that we've identified our formula here, we know the pieces of information, we know those values for distance and time. So speed equals 450 divided by 2.5 minutes. Now, to solve this, there's many ways you can go about this division. I am going to just use a proportional relationship because I know if I multiply this by 2, that's 5. So I need to multiply this by 2 as well, and that's 900. So now I'm doing 900 divided by 5. And that, I know, if it was 90 divided by 5, that's, let's see, I think it's, let's see, 18, I want to say, because that's a 500 and a 400, and 500 divided by 5 is 100, and 400 divided by 5 is 80. So our answer is 180. So we know that Melanie ran 180 meters per minute, according to that triangle and according to the formula. So if we were to double check ourselves, using our rate line from earlier lessons, we're doing meters per minute. So we have meters per minute. And if I look at this, that seems to match up. We have distance per time, or distance on top of time, and that's great. So the question is how many meters in 1 minute? And we know 450 meters in 2.5 minutes. So to figure out how 2.5 becomes 1, we divide that by 2.5, and we would need to do that same division here. So to solve that out, using our rate line, 450 divided by 2.5. And as you notice, the math we do here based on our rate line is the math that matches the formula we got from that triangle. So a lot of these problems is just going to be identifying what you know and then what you need to find out, and like the relationship between those things, and then doing some math. So you'll have to identify, am I making mistakes on picking the right formula, or am I making mistakes on the correct calculation? Is it a computational mistake? So now if we look here, Mr. Plaskett drives. This is a vehicle that I saw in the parking lot at the beach one day and thought it was beautiful and wanted to steal, but I didn't because can't steal. Here we go though. We know Mr. Plaskett drives at a speed of 65 kilometers per hour. Ooh, so I'm already noticing we have a speed of 65 kilometers per hour. Our units for distance is kilometers. Our unit for time is hours. At this speed, how far does he travel in 2 hours? So we're asking a question about distance, and we know our time. So, according to our triangle, distance equals, and now speed and time are right next to each other, so speed times time. And we'll look and see if this makes sense, of course, at the end. So, according to that formula, our distance on how far I travel is my speed, 65 kilometers per hour, times 2 hours. And 65 times 2 is 130 kilometers. That's how far I travel. Now, I'm going to think about this here using our rate line again, where we know we're doing kilometers per hour, and I'm traveling 65 kilometers in 1 hour. How far do I travel in 2 hours? Well, to go from 1 to 2, we're traveling twice as long, so it seems reasonable that we would be traveling twice as far. So again, our, let me see, what's that? Like our unit rate or our rate line on the left over here seems to match up and give us the same calculation that we would use with that formula from the triangle. And then we could do the same thing for number 5. We'll check it again, where distance equals our speed of 65 times 5 hours. And I know 60 times 5 is 300, 5 times 5 is 25, so our answer is 325 kilometers. And if I think about our picture up here, instead of a 2, that would be a 5, so we would be multiplying by 5. So we are good to go. Now, where the trick comes in here is when you start to see questions like this. How far does Mr. Plaska travel in 1 minute or 1 week? And the difficulty here is our speed is given to us in 65 kilometers for 1 hour. And so we have a mix-up of units of time. We have hours and we have minutes or weeks. And so before we need to figure these out, or before we need to calculate, we would have to do some conversions to solve that one. And you know what? Well, let's go into that. I wasn't planning on it, but this seems like a good road to go down. I guess pun intended, because these are traveling things. So a rate line is going to help me out again with this. I do love this very simple visual. Our units are kilometers per hour, and we want to know, we're starting out with 65 kilometers in 1 hour. And the question is asking, how far would I travel in 1 minute? So that's a question mark of distance for 1 minute. Well, now, I mean, if we just looked at these numbers and ignored the units, that seems like a 1 times 1. So I would multiply it by 1. And so in 1 minute, I would travel 65 kilometers. And I'm thinking to myself, is this reasonable? If it would take me, if we know it takes 1 hour to drive 65 kilometers, would it be reasonable to think that I would also drive 65 kilometers in 1 minute? I know a minute is a shorter amount of time, so that one can't possibly be right. So I'm going to back up and see what I need to do to make my units match up. And I know that 1 hour is 60 minutes. And so now if I'm at 60 and I need to get to 1, I'm going to have to divide by 60. So up here, rather than doing some multiplication, I need to divide by 60. And so I end up getting 65 divided by 60, which is 1 and 5/60ths, or let's see, 1 and 1/12. So I could travel 1 and 1/12 kilometers in 1 minute. And if we're thinking about being reasonable, 60 minutes, 65 kilometers. So I'm traveling just about 1 kilometer per minute if I'm traveling almost 60 kilometers in 60 minutes. So this does seem to be a reasonable answer. So it just takes a little bit of looking at what are my units, what is the relationship between them, and then how can I use those things to do my end calculation. So far, here we've calculated speed. Here we've calculated distance. So the last thing that we're going to have to look at is calculating time. So according to our triangle, before we even get started, I can quick sketch that out. We know time, and that is going to equal distance divided by speed. Because again, we have distance, imagining that's our line on our fraction, is over the speed. So time equals distance over speed, or time equals distance divided by speed. So Christopher ran around a field at a speed of 6 meters per second. How long did he take to run 456 meters? So my first check, we have meters and we have meters, and so we are good to go on that. And this is a question of how long. So we want to know time equals our distance divided by speed. So time, how long it took him, is our distance, 456, divided by 6. And that's going to tell us how long it took us. Well, let's see. I know, I'm going to use some branching on this one, that a 420 and then a 36. If I break that 456 into those two numbers, because they are both easily divisible by 6. 42 divided by 6 is 7, so that's 70. 36 divided by 6 is 6. So it took 76 seconds, or 1 minute, 16 seconds. Both of those are the same. Both of those work out. Now, we haven't calculated time yet, so I am going to do a quick rate line to see if this formula matches what we would see on our rate line, because it's really hard to argue with that rate line, especially when we're doing meters per second. We know we travel 6 meters in 1 second, and our meters is 456 in how many seconds? So 6 times something is 456, because that's what we would have to multiply by here. And I know from earlier lessons that 6 times something equals 456 can be calculated by doing 456 divided by 6 is going to give us that something, because I know that relationship between our multiplication and division. And if you check it out here, 456 divided by 6 is our formula that we got for calculating that time. So it does seem like we would have to multiply by 76, multiply by 76. There you go. So that is us calculating time. So in all of these videos we've seen, or in all of these problems so far, we've seen that this triangle that captures the relationship between distance, speed, and time maintains true even when we check it against using that rate line to just see conceptually does it match. So for those three things, now as we move forward, instead of taking the time to draw out this particular rate line to determine the formula, I am just going to rely on that triangle. But know that that relationship is based in actual math. So now we're going to be applying this in a couple more complex problems. So this one is extending from just calculating distance, time, or speed into calculating average speed. So average speed is very similar, but just a little bit different, where you take your total time, total distance rather, because I know from here, dt, that speed is distance divided by time. So you take your total distance and you divide that by your total time. So for this one, tree A and tree B are 9 meters apart. Tree B and tree C are 21 meters apart. Andy ran from A to B in 2 seconds, then B to C in 3. Draw a diagram, then find Andy's average speed for the distance from A to C. So if we think about this visually, we have A to B to C. And now, as you can tell, like mine is not drawn to scale. I am going to scooch it just a little bit, because we know A to B is 9 meters apart, so our distance is 9. And then B to C, that distance is 21 meters. He ran from A to B in 2 seconds, and then from B to C in 3 seconds. So it looks like he got up to speed and then was a much faster runner. So to calculate this average speed, we need to know what was his total distance and what was his total time. And so his total distance is going to be the 9 from A to B and the 21 from B to C, so 30 meters. And then his total time is, well, it was 2 seconds from A to B and 3 seconds from B to C, so his total time is 5 seconds. So to calculate our average speed, we would need to do our total distance of 30 divided by our total time of 5, and we would get 6 meters per second. And so over the course of this run, his average speed was 6 meters per second. But we know he didn't run exactly 6 meters per second the entire time. There was like some moments where he was running a little bit faster, some when he was running a little bit slower, but average tells us we need to balance that out and see holistically over this entire distance for that entire time, what was his speed. So similarly, let's look at this one. You know what, I feel pretty good about that actually. We could look at this problem for Alexander. You know what, how about this? Take a moment, find his total distance, find his average speed. So do a quick sketch and see what you can come up with. So pause the video now, solve it, and then we'll come back and look at it together. Okay, so Alexander has broken his swim into 2 sections. We have part 1, where he swam for 100 seconds, and then part 2. Okay, so I gotta organize this information to see according to my triangle, because this is like the key that unlocks it. What do I know? What don't I know? We know this first part, his time was 100 seconds, and his speed was 1.4 meters per second. He then swam another 360 meters. Ooh, that's a unit of distance. 360 meters. And took a total of 400 seconds to complete the entire swim. So our total time here is 400 seconds. So now if we want to find his total distance, we need to figure out, we don't know his distance for the first part. But I know for my triangle that if I know time and speed, I can calculate distance, because distance equals speed times time. So if I look here, for that first part, they give us those first two values, so I can calculate that second one and get that missing piece of distance data. So we need to do 100 times 1.4. And I know multiplying by 100 moves our decimal point 2 places. So in that first part, Alexander swims 140 meters. So if I know this first chunk is 140 meters, this second chunk is 360 meters, we know his total is going to be both of those pieces, or 500 meters. Awesome. That's pretty great. So now if we want to find his average speed, we need to know his total distance divided by his total time. Well, we're in luck because we just calculated his total distance. They gave us his total time. So this one's going to be pretty straightforward to calculate. 500 divided by 400. And I'm going to set this up, and I know I could use proportional relationships where if I divide by 100 for both of these, it's essentially getting rid of those two zeros. So I have 5 divided by 4, or 5/4, which is 1 1/4. So his speed is 1 1/4 meters, per second, according to this problem. There is his average speed. You could write that as a fraction, you could write that as a decimal. It doesn't change how fast he's swimming. But in the next video, you're going to see how taking a moment to organize this information and then to identify this was the piece that we didn't know that would allow us to calculate his total distance. So if you know two pieces, you can then calculate the third and then start to put it together. So hopefully this makes sense. If not, you can go back and rewatch them as we calculate distance times speed for word problems.